Hi everyone, in today's lesson we're going to talk about double and half angle formulas. First, let's talk about double angles. So question number 1 says, if cosine of A is equal to 5 over 13, where 90 is less than A, which is less than 180, find first sine of 2A. So just like we did yesterday with the sum and difference formulas, we need to draw a picture. So they tell us that angle A is between 90 and 180. So to me, that means I have an angle in quadrant 2. So I'm going to draw the bow tie in quadrant 2 with angle A being here. And it says cosine. Remember, ca for cosine is adjacent over hypotenuse. So adjacent to angle A is here, which we'll call 5, and the hypotenuse side we'll call 13. Now we're likely going to need the hypotenuse side, so I'm going to go ahead and solve that. So we've got a squared plus b squared equals c squared. Remember that c is the hypotenuse and one of the legs is missing. So 5 squared is 25, 13 squared is 169. If we subtract 25 from both sides, we should get 144, and the square root of 144 is 12. Okay, so now that we have a clear picture, we can go ahead and answer part A. Part A says find sine of 2A. So the formula for sine of 2A is simply 2 sine A cos A. And I'm going to put parentheses around the A. Okay, so sine of A, if this is angle A, sine is opposite over hypotenuse. So opposite and hypotenuse. So sine is 12 over 13. And since this is attached by multiplication, we're going to multiply this by 2. It would be in your best interest to put the 2 over 1 so that you know you're multiplying tops with tops, bottoms with bottoms. And now cosine of A, the next part, cosine we already have, is 5 over 13. But we have to make sure we understand what quadrant we're in. So since we're in quadrant 2, we know that sine is the only thing that's positive. So we must make cosine of A negative. So negative 5 over 13 is actually what it's equal to. And technically, in the beginning of the problem, this should have said negative 5 over 13 as well, but that's why. So now if I want to find the exact value of this, I could do it by hand or I can just type it into the calculator. So why don't you actually do that? Take a minute, pause the video, type this in, and then hit resume when you're ready for the answer. Okay, so I got negative 120 over 169. And that's it. That's its exact value. Exact value is really a fraction, not necessarily a decimal. If they wanted you to round it to a nearest tenth or hundredth, they would have said so. So leave your answer in fraction form if necessary. Okay, so now cosine of 2a. So there are 3 formulas that you could use for cosine of 2a. So what I'm actually going to do is I'm going to do one of the formulas, and then I'm going to ask you to do one of the other 2. So I'm just going to do this one. And that formula tells me that cosine of 2a is equivalent to cosine of squared of the angle minus sine squared of the angle. Now, what's important to know is that this little squared here on the inside means cosine of a, that whole thing squared. Same thing over here. If it was sine squared of a, that means sine of a, that whole thing squared. It's just notation. So for whatever reason, the textbooks will always write the squared on the inside, but what it means is this whole thing squared. So it's really important that we know that. So we already found what cosine of A was previously, right? Cosine of A was negative 5 over 13, and we know that sine of A was 12 over 13. So we're just going to plug into this formula. So my cosine of A is negative 5 over 13, and we're going to square this, minus sine of A, we now know is 12 over 13, and we're going to square that. Now, lucky for you, the calculator can do all of this. So take a minute, pause the video, type this into the calculator just the way you see it, and then hit resume when you're ready for the answer. Okay, so what I got here was negative 119 over 169. That's your exact value. All right, so what I'm going to ask you to do now is try another formula. So pick one of the other 2 and prove it. Prove that you get the negative 119 over 169. So I already did the first one. So feel free to try this formula or this formula. And your goal is to see that you get the same thing as we got here. And then when you're done with that one, I'd like you to also do tangent of C for homework. So these two we're going to do for homework. All right, let's move on to the next page. Okay, so this back page is all about half angles. So look at the first question. It says, if cosine of x is 1/9, find sine of x over 2. Don't let the x over 2 worry you. It's really the same thing as 1/2 of x or 1/2 of a. Now it says where x is a positive acute angle. That means we're in quadrant 1 where everything is positive. So you see this plus or minus? That means we're going to choose the positive because we are at a positive acute angle. So we're going to write down the formula that we're going to use. And we're going to use the square root of 1 minus cosine of, I'll use x, over 2. So let's plug in what we know. We know that cosine of x from here is 1/9. So 1 minus 1/9 all over 2. Now, you probably could put this whole thing into the calculator, but you want to know how to do it by hand because sometimes the calculator won't give you the correct exact value. It'll give you the decimal equivalent. So what we're going to do is we're going to do this in pieces. So you can use the calculator for some of it. Just don't put the radical in. So what I want you to do is put just this part into the calculator. Don't put the radical. And tell me what you get when you do that. So hit resume once you're ready. Pause the video and then hit resume once you're ready. Okay, so what I got here was 4/9. So we need to take the square root of 4 over 9. So what's helpful to know is that when you take the square root of a fraction, you take the square root of the top and the square root of the bottom separately. So the square root of 4 is 2 and the square root of 9 is 3. And that would be your final answer. So again, the reason why we didn't put the square root into the calculator was because sometimes we may not get perfect squares here and the calculator will spit out a decimal. So it's important to know you can use the calculator to simplify this piece, but make sure you're doing the square root part by hand. Okay, take a look at question number 8. What I'd actually like you guys to do right now is try this one on your own using the cosine of 1/2 x formula. And we can check this one tomorrow as well. So we'll make 8 homework as well. All right, let's take a look at the last part. The last part now is we can use these identities to help us simplify expressions. So if you take a look at this first example, this says 1 plus cos 2x over sine 2x. Well, I know that there are 3 formulas for cosine of 2x. So what I'm going to do is actually use the bottom one first and then see where that brings me. So the bottom is sine of 2x, which is this formula. So it's 2 sine of x cos of x. And on the top, we have a 1, and we need to add to it the cos of 2x formula. So you want to use a formula that you think would be most helpful to you. So you want to analyze these 3 and see which one might be the most beneficial. I'm looking at them and I'm thinking this one. And the reason why I'm thinking that one is because there's a positive one here that I could cancel with this negative one. And I can't do that with any of the other ones here because there's a 1 that would add to 1 that would be 2, right? So I'm thinking this one would be your best bet. So we're going to make this 2 cos squared x and then minus 1. And like I said, these will cancel. And that makes this simplified. So I have 2 cos squared of x over 2 sine of x cos of x. And what you're going to notice, more things will cancel. You should notice that the 2's in front will cancel. There's 2 coses on top and 1 of them on the bottom. So the leftover cos is on top. So we've got cos and sine. So my final answer is cosine of x over sine of x. And you should remember that cosine of x over sine of x simplifies to cotangent. So this would be my final answer. All right, I'd like you guys to try example number 2 here. Try to see what you can do with it using the identities over here, and we'll reconvene tomorrow. All right, have a good night.